Okay, let's talk about nicotine. When you hear that word, what's the first thing that pops into your head? Probably addiction, right? Disease, the whole tobacco epidemic. And yeah, that's a huge part of its story. But what if I told you there's another side to it? A hidden history, one that's all about medicine, sacred ceremony, and a really surprising power to control our body's most basic defense system. So yeah, let's just dive right in because this is the big paradox we're going to unpack. How can something we see as public enemy number one also have this long, long history as a sacred medicine? And get this, how is it now at the very center of some super cutting edge research for its healing properties? It just doesn't seem to add up, right? All right, to even begin to make sense of this, we've got to go way back. I mean, long before anyone even thought of rolling a commercial cigarette. The way people saw this plant, it was completely different. For literally millennia, indigenous peoples here in the Americas grew and used tobacco. But it wasn't just some casual habit, not at all. It was a deeply respected spiritual tool. It was used for prayer as a sign of respect and was a key part of healing ceremonies. They believed it could help with all sorts of things, from pain to breathing problems. And as we're about to see, modern science is actually starting to find some surprising evidence for that. And this timeline, wow, it really lays out the wild roller coaster ride tobacco's reputation has been on. It starts as this sacred ceremonial plant. Then, in the 1500s, it gets to Europe, and a Spanish doctor calls it a panacea, a cure for like 36 different things. Fast forward to the 20th century, and boom, it's public enemy number one. Understanding this crazy shift is absolutely key to getting the whole story here. Okay, and this slide, this really gets to the heart of it. We have to be super clear, we are not talking about the same thing. The traditional ceremonial use of a pure plant is a world away from a modern, mass-produced cigarette that's packed with hundreds of chemical additives and designed to be addictive. This difference is so important for everything we're about to talk about. All right, so we've got the history down. Now let's switch gears and get into the biology, because this is where things get really interesting. Where does nicotine actually do its thing in the body? Well, the answer, it's probably not what you're thinking. I bet when I say nicotine, your mind goes straight to the brain, right? You're thinking about dopamine, addiction, maybe that feeling of focus. And yeah, that's the story we all know. It's totally true. But it's only chapter one. But the real story, the big secret here, is that the places where nicotine docks in our body, these things called receptors, they aren't just in our brains. They are literally all over the place. And amazingly, they're found right on the cells that control our entire immune system. And look, this isn't just some wild idea. We have the data. This table shows it pretty clearly. Our major immune cells, we're talking T cells, macrophages, dendritic cells, they are all just covered in different kinds of nicotine receptors. It's almost like they're all radios tuned to the exact same station, just waiting for a signal. So what happens when nicotine hits play? Okay, this is where it gets really mind-blowing. When nicotine actually connects with those receptors, it does more than just, stimulate them. It can literally flip a huge biological switch, a switch that controls inflammation in our bodies. Now, this whole process has a big science-y name, the cholinergic anti-inflammatory pathway. Don't let that throw you, though. The concept is actually pretty simple. Basically, your nervous system has a direct phone line to your immune system. And when inflammation is getting out of control, it can use that line to send a, hey, calm down signal. What nicotine does is, well, it can basically pick up that phone and make the same call. Here's an even simpler way to think about it. Imagine an immune cell, let's say a macrophage, is covered in little keyholes. These are a specific type of receptor called alpha-7. And it turns out nicotine is the perfect key for that lock. When that key slides in and turns, it sends a powerful stand down message deep inside the cell. So it's a really elegant little process, right? Step 1. The nicotine binds to the receptor. The key goes in the lock. Step 2. That triggers a chain reaction of signals inside the cell. And step 3, the big payoff. The cell just slams the brakes on producing these pro-inflammatory molecules called cytokines. And those cytokines are the gas that fuels the fire of inflammation. Now, it would be super easy to just stop right here and say, wow, nicotine is a miracle anti-inflammatory. But you know how it is with biology. The reality is always way more complicated. And in this case, a lot more controversial. Because here's the twist. It turns out not all those keyholes on the cell open the same door. That alpha-7 receptor we talked about, that seems to be the main off switch for inflammation.
But activating other receptors, like one called alpha-1, might actually do the opposite. It could be an on switch for the exact kind of inflammation that can damage our arteries.
And there's another huge catch. We need to remember that inflammation isn't always bad, right? When it's short term, it's a critical part of how we fight infections and heal. So, constantly pushing that off switch can be a real double-edged sword. And the research is pretty clear on this. Long-term nicotine exposure can actually make it harder for us to fight off something like the flu, it can weaken our immune cells, and it can even make us heal slower. So all this complexity, as you can imagine, is fueling a pretty intense debate. On one side, you've got people like Dr. Brian Artist, who's very direct about it. He basically says if you have a condition that ends in itis, arthritis, colitis, whatever, that means inflammation, and nicotine turns it off. Simple as that. But then, on the other side, you have researchers like Jonna Moyne, an immunologist who's deep in this stuff. And her take is, well, it's way more complicated than any one simple theory. She's saying the effect is so much more complex, which is a much more cautious, nuanced way of looking at it. And this isn't just a theoretical debate. It is playing out right now in the long COVID community. You have thousands of people who are just desperate for anything that might help, and they've started trying nicotine patches. It's become this huge, informal, patient-led experiment. But the results are all over the map. Some people report feeling a lot better, but others say it actually makes them feel worse. It's just a huge reminder of how much we still have to figure out. So where does that leave us? Well, we're stuck with this molecule that is just full of contradictions. And figuring out the future of it means we have to tread really, really carefully. And this really sums up the whole puzzle, doesn't it? On one hand, you have the risk. And let's be real, it's a huge risk. Nicotine is one of the most addictive substances known to man. But on the other hand, you have this incredible potential. It seems to hold the key to one of our body's most powerful systems for controlling inflammation. And this is probably the most important thing to take away from all this. For scientists, the goal is not to tell everyone to start using nicotine patches. The goal is to learn from nicotine. It's about understanding exactly how it communicates with our immune system. Because if we can figure that out, we might be able to create brand new therapies that give us all the anti-inflammatory benefits without any of the addiction, the side effects, or the danger. That's really the big question driving all this research, isn't it? Can we separate the healing from the habit? Can we untangle the good parts of this ancient plant from the really destructive parts of its modern version? It's pretty wild to think about. The key to fighting some of our toughest inflammatory diseases might have been hiding in plain sight this whole time, locked inside this one controversial molecule. The real challenge now is, can we be smart enough to unlock its power without falling into its trap?